Hello, so we are back, and so we were in the middle of crisscross. So where was I? Yeah, so sorry, we were on test 30 and we were doing graph G, so let me finish that off. CD is 8, CE is 0, DE, so 4, and then that should be the final one. This is what we get. Let's compare it. So the cost is 20, yes. Our edges are DE, yep, EA, yep, DB, yep, DB, and BC. So that works, and you can see that the order of showing the edges is different than if we used prims. So there are slight differences in which they work, but they will show the same total minimum cost. Sometimes, sometimes prims might show different edges depending on the graph, but it works, and crisscross works in the system. Now, again, if we have an unconnected graph, however, we need to know how to tackle that. So we're going to use our handy old graph B, which we've been using. And if we see what happens, the graph is unconnected, hence the minimum spanning tree cannot be found. Wonderful. So let me just check this is recording. Oh, good, it is. Okay. Now we move on to root inspection. So we've done 2/3 of our overall testing, and now we're on the last and final part of our root optimization algorithms, which involve finding cost of minimum roots or finding roots themselves. So test 32. So checks for a graph H inputted. The algorithm shows the shortest cost of traversing a path which visits each edge at least once. So for graph H, this is our expected result. So let's input graph H into the system and see what we get. So so how many nodes are there? First of all, there are 5 nodes, and A to B is 8, A to C is 0, A to D is 7, 8, 0, 7, E to E is 5, then we have B to C 6, B to D 0, B to E 6, so 6, 0, 6. Then we have C to D 9, C to E 7, so 9 and 7, and our final one D to E 4. Sorry, D to E 4. This is the screen which is displayed. Let's have a look. So the cost is 65. The length of the shortest route which traverses each edge at least once and returns to the start is 65. The edges to revisit are AD, BC, and it says here that the edges to be retraversed are AD and BC respectively.